Hey everybody, so let's dive into some more organic chemistry questions, and this particular question says the structure of an organic compound is shown, and obviously right off the bat you could notice the OH functional group, which indicates that it belongs to the family of alcohols, right? The homologous series is alcohols, and because it has 3 carbons, meth, eth, prop, we can safely say that the name of this alcohol is propan-1-ol because the functional group is on the first carbon, or you could just call it propanol, who cares, right? Because the requirement of the question is which structure represents a molecule that reacts with steam. Steam is what? H2O gas, right? So which reacts with steam to produce this product. Which particular family reacts with steam to produce alcohols? Well, we already know that that family is my alkene, right? And that alkene basically undergoes this addition reaction with steam known as hydration, and therefore B and C right off the bat are wrong, because they are not alkenes. Alkenes are unsaturated hydrocarbons, and unsaturated means that it must have the carbon-carbon double bond, right? So this has a carbon-carbon double bond and this has a carbon-carbon double bond. Now the question is, which of these two options is correct? Is A correct or is D correct? Well, it's pretty simple to eliminate A off. Why? Because the alcohol consists of 1, 2, 3. It consists of 3 carbons, so it must be made from an alkene which had 3 carbons, right? And if I show you this reaction, it's pretty simple, it's just a wastage of time. But if I still show you this reaction, what's going to happen is that you have a structure like so. That's your prop-1-ene, and what's going to happen is when you react it with steam, this double bond right here, this is going to break. Obviously, let's break it. So this double bond right here is gonna break, and once this double bond breaks, on one hand side you're gonna have the H being bonded, and on the other hand side you're gonna have the OH being bonded. So the resulting product will look something like this, right? So these are my already bonded atoms, and this is the new H, and obviously that's the O bonded to the H, which is exactly identical to the structure shown in the question, and therefore D is the correct option and A is wrong. You don't need to go into so much detail when you are solving an MCQ. I was just recalling concepts, right? And fun fact, what are the conditions? Well, the conditions are you need a catalyst which is acidified acid, and for now it's acidified acid, but you could also write acidified phosphoric acid, which we usually use, but now your syllabus says you just need to know it's an acidified acid, right? But many past paper questions will have acidified phosphoric acid in their MCQs. Done. And the temperature that you need to provide is roughly 300 degrees Celsius, and the pressure should be 60 to 70 atmosphere. Usually we quote a value which is normally 70 atmospheres. Done. So that is MCQ number 1. Number 2, which describes nylon? Is it an addition polymer? No, sorry. Your alkenes undergo addition polymerization. Nylon undergoes condensation polymerization because it is made up of dicarboxylic acid and diamine undergoing a condensation reaction where a small water molecule is removed or eliminated, right? And the linkage that forms is basically a carbonyl carbon bonded to the NH, right? And that is why this nylon is also known as a polyamide, because this particular linkage is the amide linkage, right? And you could also call it a polypeptide in biology, because in bio we usually use the words amide, and we use the word amide and peptide interchangeably, right? That's for the bio geeks, but in chemistry we call this group as the amide group, right? And this linkage is the amide linkage essentially, and that is why we call this polyamide. Done. And nylon is basically a synthetic polyamide, not a natural polyamide. What's a natural polyamide? That's basically your proteins, right? So is it a natural polymer? Absolutely no. It's man-made, it's synthetic. Polyamide, absolutely it's a polyamide. Is it a polyester? No. For it to have an ester linkage, you must have had the carboxylic acid functional group reacting with the alcohol functional group, right? So you must have had a dicarboxylic acid and a diol, just like in PET, polyethylene terephthalate, also known as terylene, or just like in fats, right? But the beauty is that fats is a natural polyester and PET or terylene is a synthetic polyester. So C is also wrong. D is also wrong. Which diagram represents the structure of the product from? And if I remember this question correctly, it's not properly posted. It says ethene undergoes polymerization. Yes, it says ethene undergoes polymerization. Which diagram represents the product form? Well, obviously, if ethene undergoes polymerization, it's going to undergo addition polymerization. So what's going to happen is you have your ethene monomers, and this double bond right here, this double bond is going to break, this double bond is going to break, this double bond is going to break, and they're all going to bond with each other, forming a polymer that will look something like this. So when the double bond breaks, I've broken the double bond, I've broken the double bond, I've broken the double bond, and you just join them, right? So that's joined right here, that's joined right here, and these are my connectivity bonds. Now, this is when you're making 3 repeat units. In your options, you're not asked to make repeat units. What they have done is they've represented each repeat unit or each monomer with the number, with the letter N, right? So this N basically refers to the number of monomers. So if you just wanted to make a polymer out of ethene, not knowing the number of monomers, what you would do is you would make this structure as it is, and you would make your connectivity bonds, and instead of making the number of repeat units or making the monomers, we use the letter N, right? So this N basically represents all these monomers. So if N is 3, that means that the structure will look something like this, right? That's the generic form of making an addition polymer like polyethene. So between A, B, C, D, which is the correct option? Obviously C is the correct option, Reno. And B is wrong. Why? Because the double bond is supposed to break. A is wrong because that's just the ethene monomer, dude. And D is wrong because again the double bond is gonna break, man. The double bond needs to break, and what in the world have you made? You've made meth, eth, pro, bute. This is basically butene that the person has made. Seriously, it can be so, the options can be so silly at times, right? It says which pair of compounds are structural isomers of each other. Now, in order for these pairs to be structural isomers, isomers are 2 or more compounds having the same molecular formula. So the molecular formula should be the same, but different structural formula, right? So their structures are different, structural formula. Now, firstly, we have to check out if we have to save time. So in order to check out whether they're isomers, I'll first check if they have the same molecular formula. A right off the bat is wrong. Why? Because here you have meth, eth, prop. Here you only have 3 carbons, whereas in this particular molecule you have 4 carbons. So the molecular formula cannot be the same, because in one place you have 3 carbons and in another place you have 4 carbons. Therefore, I can safely eliminate A out, right? Now, for the others, I have to draw them. So let's draw our B. B says you have CH2 double bonded to a C bonded to an H, which is bonded to a CH3, right? So that's basically meth, eth, prop. That's prop 1-ene, right? And if you make, this is molecule A, I'll label it right here. That's molecule A. Now if I want to make B, I can do so. So that's CH3, that's C bonded to H, and then it's double bonded to ACH2. Remember, this is absolutely, they are both the same structures. They are not structural isomers. Why? Because if you name them, you're going to select the longest carbon chain, which is right here, unbroken carbon chain, and we start numbering from the side where the double bond is the closest. So here, meth, eth, prop. And this particular structure is known as prop 1-ene, right? Because we use the number which is a smaller number between the two, right? So between 1 and 2, the smaller number is 1, and we're going to insert it between prop and ene, right? So we're going to say it's going to be called prop 1-ene. I'll write it here. This is prop 1-ene. Now again, if you name structure B out, you're going to select the longest carbon chain, unbroken carbon chain, and we start numbering from the side where the double bond is the closest. So it's closest to the right hand side, therefore we start numbering here, and let's name it. So prop and ene will have the number of the functional group. So between 1 and 2, which number are we going to insert here? The smaller one, 1. So this is also prop 1-ene, and that's also prop 1-ene. Therefore, they mustn't have the same structures. They mustn't have different structures. They are the same structures. Done? If you check C out, C says you have CH2 bonded to the OH. So it's CH2 bonded to the OH, which is bonded to CH2, which is bonded to CH3. And this particular molecule is CH3 bonded to CH2 bonded to CH2 and bonded to the OH. Again, they are the exact same structures, because if you name them, this particular structure is meth-eth-pro-propan 1-ol, because the OH is on the first carbon, and this particular structure is also meth-eth-pro-propan 1-ol. Remember, we start numbering from the side where the functional group is the closest. So where the OH is the closest for this case. So they are both propan 1-ol. So C is also wrong. And therefore D should automatically be my correct option. But let me also prove it for you. So that's CH3 bonded to CH2 bonded to CH2 bonded to the carboxylic acid functional group, right? So CH3 bonded to CH2 bonded to CH2 bonded to COOH, which is the carboxyl functional group. And this particular fella, this is CH3 bonded to C, double bonded to O, single bonded to O, bonded to CH2, bonded to CH3. So they have the same molecular formula. You can count the number of carbons, oxygens and hydrogens, but they have different structural formula. They are functional group isomers. So structural isomers further has three categories. Chain isomerism, position isomerism, and functional group isomerism. These particular molecules, these fellas, are functional group isomers. Why? Because their functional groups are different. This is an acid functional group, and that's basically my ester, right? So D is the correct option. You could have done this particular MCQ in less than 30 seconds, right? I have to explain each and everything, so it takes me time. This says methane reacts with chlorine in sunlight. Why in sunlight? Because it provides it the activation energy, right? The UV rays or the UV light provides this particular reaction with the EA, and this is a substitution reaction, right? Which statement about this reaction is correct? It is a substitution reaction, absolutely. So a chlorine atom substitutes a hydrogen atom, and the hydrogen atom that has been substituted reacts with chlorine to make HCl gas. Remember, this is not hydrochloric acid, this is hydrogen chloride. It is an addition reaction? No sir, it is a substitution reaction. It is not an unsaturated hydrocarbon or an unsaturated molecule. This is a saturated hydrocarbon. Your alkanes don't undergo addition reactions. They are generally unreactive, right? It is a photochemical reaction, absolutely, because photo literally means light. So it's a reaction which requires light. It does. It's stated right here, sunlight. It requires sunlight, so it is photochemical. Photo means light, right? So it requires light. Done? So yes, that's true. 1 is true and 3 is true. Fourth is, it is catalyzed by nickel. No sir, there is no catalyst requirement here. The reaction which is catalyzed by nickel is basically hydrogenation, the addition reaction of an alkene with hydrogen, right? Here you need nickel solid and a temperature of roughly 200 degrees Celsius, done? And this gives you an alkane. So 1 and 3 are the correct option. 4 is wrong. This MCQ says propene reacts with bromine to give one product only. Obviously, it's going to give you one product. No wonder it's called an addition reaction, right? So addition reactions are reactions in which only a single product forms, right? And that's why the bromine decolorizes. So if this is propene, meth-eth-prop, right? So that's propene right here. And what happens is you're reacting it with bromine. So this double bond is going to break, and one Br is going to bond here and the other Br is going to bond right here, right? So what's going to happen is the double bond breaks, boom shakalaka, and one Br is bonded here and the other Br is bonded here. You know, you could have safely presented this Br here, this Br here, but remember, one thing to note is that wherever the double bond is going to break, the new atoms are going to bond there. The atoms are going to bond wherever the double bond breaks. Remember, you can't bond a Br here and the other Br here. No, the Br atoms bond where the double bond breaks. Any type of atom, if it undergoes an addition reaction with an alkene, these atoms, whichever these atoms are, be it HCl, be it Cl2, be it, you know, H2O, they're gonna bond wherever the double bond breaks, right? So A is absolutely wrong. Why? Because he's saying that the Br2 are gonna bond on the same carbon, whereas that's wrong, right? Because he's saying CHBr2, which means both the bromine atoms are on this particular carbon. No, we know that each bromine atom is on their respective carbon. So wherever the double bond breaks, one Br will come on one carbon and the other Br will go on the other carbon. Again, see, B is wrong because he is bonding the bromine atom to this carbon right here and one bromine atom to this carbon right here. So that's absolutely wrong. There's so much space between them. B is wrong. And we check C out. C is therefore correct. Why? Because one bromine atom is bonded to this carbon and the other bromine atom is bonded right here. And I can show it to you guys. So that's CH3 bonded to a hydrogen, bonded to hydrogen, and here you have a Br and that's the other Br, right? So it doesn't matter, the orientation does not matter as long as the bromine atoms are bonded where the double bond breaks, right? So C is correct. I will check D out. D only shows one bromine atom, whereas it's an addition reaction, therefore two bromine atoms should be added to the product. Now it says ethanol can be manufactured by fermentation or by the catalytic addition of steam to ethene. For fermentation, what do we need? We need glucose, right? We put water in it, we add water to it, and obviously we use a catalyst which is yeast, provide a temperature of around 35 degrees Celsius, anywhere from 25 to 35 degrees Celsius, and therefore you get 2 moles of ethanol and 2 moles of carbon dioxide. But the problem with this particular reaction, it's very slow, it's a batch process, it's a slow process, but the ethanol that we get is very, very pure, right? Because here you're going to get 15% ethanol, but you could perform fractional distillation, which is going to give you 99% purity, right? The alcohol is going to be 99% pure then, right? And why is this going to be 15%? Well, obviously because you've added water here, right? So it's going to be diluted. Now it says, which statements describe the advantages of manufacturing ethanol by fermentation? The advantage is that, you know, the biggest advantage of fermentation is that you're using renewable resources, right? So the raw material is glucose, which is renewable. You're not going to run out of glucose. Yes, as Muslims we believe that क़यामत आएगा, but it's still renewable, right? क़यामत के दिन तो सब दरख्त भी खत्म हो जाएंगे. Done? Now it says the yield of ethanol is low. That's not that's not an advantage of ethanol by fermentation. That's a disadvantage. But remember, the yield of ethanol by fermentation is pretty high. Why? Because you could get 15% ethanol and then you could perform fractional distillation on it, right? So in some books it says that, you know, it's high because you perform fractional distillation, but initially you could say it's low, and even then, you know, you need to use your brain and say that, hey, it's not an advantage. If the ethanol yield is low, that's not an advantage, that's a disadvantage, right? Then it says the method uses a batch process. Again, batch process means it's a slow process. It's going to happen in batches. So first you're going to get ethanol and then you're going to process it into fractional distillation and then you're going to get pure ethanol. So it's a long ass process. It's a batch process. It takes place in batches. First you make this, then you go on to the fractional distillation bit. So that's not an advantage. Again, disadvantage. The process takes place at a lower temperature. Yes, that's an advantage. Why? Because obviously compared to the addition of steam, you need to provide 300 degrees Celsius when you're doing the addition, when you're making, when you're making ethanol by the addition of steam, you need to provide a temperature of 300 degrees Celsius. Here, you only need to provide a temperature of 35 degrees Celsius. So the process takes place at a lower temperature, therefore less costs, less electricity costs, less reduced costs. Done? Now it says the ethanol is made from a renewable resource. Absolutely correct. So 3 and 4 are correct. Therefore D should be the correct option. A compound with the formula CH3COOCH2H5 is formed from ethanol in 2 separate reactions. Reaction 1 says ethanol reacts to form ethanoic acid, and reaction 2 says ethanoic acid and ethanol react together to form this. Which row describes reaction 1 and reaction 2? Pretty easy. Look at this. This is my ester. So how do you know it's an ester? Draw it out, right? If you can't figure it out, you draw it out. So it's C double bonded to O, which is bonded to O, which is bonded to 2 carbons and 5 hydrogens. So that's basically methane, that's ethanoic acid, and that's ethanol, right? So the ester is basically known as ethyl ethanoate, right? So that's ethyl ethanoate. Now it says it is formed from 2 separate reactions. Firstly, ethanol reacts to form ethanoic acid. So ethanol forming alcohol forming carboxylic acid is what? It's the oxidation reaction, right? So you can either do it by bacterial oxidation, or you could use the oxidizing agent, which is acidified potassium manganate, right? Acidified aqueous potassium manganate. Done? So that's oxidation, therefore C and D are wrong. And then it says reaction 2 says ethanoic acid and ethanol react together to form ester. Done? So it's basically ester formation. It's not an addition reaction, it's a condensation reaction. So therefore A should be the correct option. Moving on. The flow diagram shows how polyethylene may be made from petroleum, right? So you have petroleum, which is crude oil. And crude oil, from the crude oil you get fuel oil. So that's basically you perform the fractional distillation of crude oil. Done? And then fuel oil is basically your alkanes. Remember, from crude oil the products that you get are mostly your alkanes, right? So if alkane is going into an alkene, this means that reaction 2 is cracking. That's how alkenes are formed, right? So how do you go from alkanes to alkenes? Obviously you perform cracking, also known as pyrolysis. Done? And then from ethene you go into polyethylene, so that's basically polymerization, right? So now check it out. 1 is fractional distillation, A and B are wrong. 2 is cracking, so this particular bit is wrong, and therefore C is the correct option. 3 is polymerization. Last but not the least, methane burns in air to form carbon dioxide and water. Done? Now says which is the balanced equation. Instead of looking at it, I can just make it, right? So burns in oxygen to form carbon dioxide and water. Remember that the number of carbons you have in the hydrogen are going to be the number of carbon dioxides that are going to be made. So if you have 1 carbon, only 1 mole of carbon dioxide is going to be formed. Done? And then what we do is the number of hydrogens that you have in the hydrocarbon, half of these are going to go into water. So if you have 4 hydrogens in the hydrocarbon, only 2 water molecules are going to form. Right? Because 4 is right here, 4 atoms are here, and 2 times 2, you have 4 atoms here, right? And then you have how many oxygens on the right hand side? 2 plus 2. You have 4 O's on the right hand side. And on the left, you only have 2 O's. So what should I multiply 2 with to get 4? X is equal to 2. So I'm going to insert the 2 here. So that's going to give me CH4 plus 2O2 gives you CO2 plus 2H2O. And the answer for that is A is wrong because it's only 1 oxygen. C is wrong because it's showing 3 oxygens. And it's going to give you 1 CO2 and 2 H2O. So B is the correct option. Here it's only shown 1 H2O. Done? So that is how you need to go about the MCQs. Again, it takes me way longer because I have to go into the in-depth explanation. For you guys, these 10 MCQs should have taken not more than 3 minutes. Not more than 3 to 4 minutes. Yeah, maximum 4 minutes. Done? Pretty easy, guys. Best of luck. See you guys in the next bit. Bye-bye. Ciao.